Hello, this is section 2.4 for Calc AB, and today we're going to be discussing the chain rule. And this is actually a really big, helpful tool to find derivatives, but you're going to have to practice it and you have to be careful. And you'll see what I mean. So the chain rule is basically going to deal when you have a function within a function, which happens quite frequently. So in this case, you'll notice here's your d dx, and you have a function within a function. So you're going to do the derivative of the outside function. So that's the f prime. But notice the inside stays the same. Then times the derivative of the inside. Okay? So it'll make more sense when you see an example. And there is a nice proof on page 159. All right, so here's a classic one. So you've got a function, this 3x squared plus x, inside the function, you could say x to the fourth. This is your inside function, g of x. That's what I've written over here. And the outside function would be x to the fourth. I have seen some teachers actually have their students write this out, or they'll have the students label the inside u for next semester. If you want to do that, go for it. That's totally up to you. Right, but identifying the inside and the outside is very important. So you first do the derivative of the outside. And here's what's nice. You can treat it like a power rule. You can pull that 4 down in front and subtract 1 from the exponent, keeping the inside the same. And then times the derivative of the inside. And it's a binomial, so put it in parentheses. So 6x plus 1, and you're done. Imagine trying to do this with the definition of derivative. Holy cow. Or you could do this if you expanded that binomial, and then you could use the power rule for each term, but oh my goodness. So much, much, much easier doing it this way. Okay. Now this demonstrates what we just did, and this is the general power rule, and this happens quite frequently. So when you have an inside function being raised to a number, you just pull the number down in front, which is what they're showing you here. Subtract 1 from the exponent, and notice the inside stays the same, times the derivative of the inside. Now, I claim you've always been doing this with the power rule. If you had x squared, you'd pull the 2 down in front, and it would be 2x. Well, technically, you then multiply by the derivative of the inside, which is just the x, and derivative of x is 1. That's what I would show you in class. And so you've always been doing the chain rule. That happens a lot in math. You've always been doing it. You just didn't realize it. You always multiply by 1. So, okay. Now these problems are going to start to get very challenging. And we're going to throw in power rule, product rule, quotient rule, all those special trig limits, and now chain rule. You have got to practice these problems. And the more you practice, the more confident you become. And honestly, the students always complain the most about, where do I stop? That's the biggest complaint, okay? So, all right, so this first one, now guys, be nice to yourself. Do you have to use the quotient rule here? No, you could move up that binomial and make it to the -2 power, because now you know about chain rule. Before, you would have had a problem, but for now, you're good to go. So you're going to pull that -2 down in front. That gives us -12. Subtract 1 from the exponent. Inside stays the same. And then times the derivative of the inside. If you stopped here, I would accept that answer. Now, I'm going to clean it up. So I'm going to move the negative exponent to the denominator and then combine the -12 and 6 to get -72t. That's your best answer. I'm starting to think into the next chapter where we're going to set this equal to 0, and you get a lot more information if you leave it like this. And it's a good idea to simplify your fraction, because something might cancel. That's where I'm going to mark you off if you don't simplify in that way, if you don't cancel what you can cancel. So it's a good idea to leave it this way just to be safe, and now you're ready to set it equal to 0. All right, so here's another one. Now, here's where you can decide. So I rewrote the radical as a rational exponent. So you can choose your path. You can move up the binomial, raise it to the -1/2, and use the product rule, or leave it this way and do the quotient rule. Either way, it's going to get messy. So it's totally up to you. You get to choose the path you go down. I went ahead and did quotient rule. So low D high minus high, and then here it comes. Here comes the chain rule. I pull the 1/2 down in front, subtract 1, inside stays the same, times the inside. All over low, low. So square that denominator. Now, I am not okay with this answer. You cannot leave it like this. You have a negative exponent. That's not good. You cannot have a fraction within a fraction. So from here, I actually factored out the common, I have a binomial. Notice both of these. Now, I know it gets a little tricky with these exponents. So pick the lower of the two. And in this case, it's going to be the negative 1/2. That's the lowest. That's what you're factoring out. Now remember, as you factor, you technically divide, which when you divide, you subtract exponents. So 1/2 minus negative 1/2 becomes 1, which you see here. And then of course, this is what you're pulling out. A good rule of thumb, because a lot of students struggle with this, is go back and check yourself. If you were to redistribute 1 plus negative 1/2 gives you back what you started with. So you can always mentally redistribute to make sure you're good to go. But here's the important thing. Look, you have a common binomial that you can move this down and write it as x squared minus 3 to the 3/2. And this is your best answer. Right? So I will get very picky with simplifying our fractions. All right, now here's one where we actually have to use product rule. So rewrite this. 5x will be the first part, and then this 3x plus 1 to the 2/3. So first times derivative of the second, and here's where I use the chain rule. Inside stays the same. Don't forget to multiply by the derivative of the inside. That's a very common mistake. It's something that you get going really fast and you'll forget to do. I forget to do it too, so you have to just be very careful. Don't get rushed. And then plus second times derivative of the first. And here's another one where this would be a good one for you to practice factoring out. Look at your exponents, pick the lowest of the two. That's this negative 1/3. That's what you'll be factoring out of those two terms. So this would be a good one for you to practice. All right, and then here, I'll move this down. And then here's one where, oh my goodness, look at all these radicals. Rewrite them as rational exponents. Okay. This is an entirely different problem. So come down here. So I pulled the whole thing up, rewrote all the exponents, and even though it looks complicated, as you go to rewrite it, actually is just a pretty straightforward chain rule problem. Pull the negative 1/3 down in front, subtract 1, inside stays the same, times the derivative of the inside. Talk to yourself as you're doing these problems. Talk yourself through the process. All right, I'll let you kind of look through these. This one would be another pick your path. Do you want to do the chain rule now? Do you want to square the binomials and then do the derivative? You've got lots of options there. You could square out both of those binomials and just do a straightforward quotient rule. There's lots of ways to do this problem, okay? Then the benefit to keeping the binomials this way is when you do eventually go to set this equal to 0, it'll be much nicer to have it in this format. But okay, and then here's a pretty straightforward product rule. Okay. All right, now find all points on the graph where the derivative is equal to 0, for which the derivative does, and for those which the derivative does not exist. So when you do this derivative, here's the derivative here. You rewrite it, set this equal to 0. So you'll notice 0 from the numerator, and that's here. But from the denominator, you're figuring out that, oh, at x equals plus or minus 2, we have an issue. The derivative does not exist. So there might be a sharp turn. There might be one of these deals. There could be an asymptote, probably not an asymptote. Whenever you have an odd radical, red flag should go up. Something weird could happen there. Okay, so watch out for those. So graph this one. Now that we know something's wrong at plus or minus 2, it's not differentiable, graph that on your graphing calculator so you can see what it looks like. And you'll say, oh, wow, okay, yeah, the slopes are not the same from the left and the right. And remember, we never say sharp turn on an assessment. That's just a slang way of describing, okay? Never say sharp turn. We never say jump in the graph. You refer to the limits approaching a different number from the left and the right. or in this case with a sharp turn, the slopes are different from the left and the right. So be more specific.